she will score a goal on any attempt is 0.7. Yes, I have three, four of you responding. So since your answers are matching, so I'm saying that, okay, all of them, that's correct. So I would appreciate that if all of you keep responding, so that if your answers match, I would assume that that's correct, okay? All right. Now, Sam is a member of a soccer club. She's practicing scoring goals. The probability that Sam will score a goal on any attempt is 0.7, independently of all other attempts. Independently of all other attempts means that every single time she attempts to score a goal, the probability is 0.7 that she will score, okay? Now, she makes 10 attempts at scoring goals. Find the probability that she will score on fewer than 8 of these attempts, right? That's a standard case of binomial distribution. You have something repeating 10 times, so it's a binomial distribution for which n is 10. What about the probability of success? This is what we're calling success, scoring a goal. What's the probability of that for any attempt? That's 0.7. What's the probability of failure? 0.3. We want to find the probability that she will score goals on fewer than 8 of these attempts. That means we want to find the probability of X being less than 8, getting less than 8 successes. What does that mean? 0, 1, 2, 3, 4, 5, 6, 7. We need to add all of these probabilities. Now, that's too many probabilities to calculate. We could reverse this. We could say that's the same thing as saying 1 minus probability of X greater than or equal to 8, which is X equal to 8, X equal to 9, and X equal to 10. These are the 3 possibilities that we've got. What's the formula that we've got for this? NCR P raised to power R, Q raised to power N minus R. What do we get from this? 1 minus N, which is 10, C8, P, which is 0.7 raised to power 8 into 0.3 raised to power 3 raised to power 2 minus 10C9 into 0.7 raised to power 9 into 0.3, and then finally we have 10C10 into 0.7 raised to power 10 into 0.3 raised to power 0. What do you get from this? What's the final result that we get from this? Okay, 0.61722. So that's 0.617. If you want to round it up to 3 significant figures, this is going to be our final result. Okay, good. Thank you. Ali, it does not say that Sam will score 7 goals. It says that she will score less than 8 goals. It could be 0, 1, 2, 3, 4, 5, 6, 7. All of those possibilities are there. Not just 7, it's all of these possibilities. Okay. All right. Find the probability that Sam's first successful attempt will be before her 5th attempt. That's geometric distribution. How do you figure that out? First successful attempts. We're talking about first success, right? Something is being repeated. We want to find the probability of getting our first success in a particular attempt. That's geometric distribution. Again, probability of success is 0.7. Probability of failure is 0.3. Now, the probability that the first success comes before her 5th attempt, that means we're looking for a probability of X being less than 5. This is geometric distribution. Now, how do you find this? You can either find the probability of X equals 1, X equals 2, X equals 3, X equals 4. That's just 4 probabilities. You can calculate them. It doesn't take that long. That's going to give you the correct result. Or another possibility is to use the inequality formula. x greater than r. The probability of this is given by q raised to power r, right? Can we convert it to that form somehow? Well, we've got greater than here, we've got less than here, so we have to do 1 minus something, right? Now let's try to understand this. Less than 5 means 1, 2, 3, 4. What we do not want is 5, 6, 7, and so on. How do you write this in greater than form? You can say subtract from 1 all of these cases, and that will give you the ones that we want. How do you write these cases in a greater than form? 5, 6, 7, 8, and so on. You would say these are greater than 4. So 1 minus probability of x greater than 4. What does that become? 1 minus q raised to power 4. And that's 1 minus 0.3 raised to power 4. That is going to give you the result. You can see what that is. Okay, I'm getting 2 different answers right now. Can others also respond? Okay, so Fazan, you're saying yours is wrong. Okay. Make sure you're rounding off correctly as well. 1 minus 0.3 raised to power 4. That's 0.9919. So you can't say that's 0.991. That will make you lose 1 mark. If you write 0.991, you will lose a mark. 9919 is acceptable. If you want to round it off, you'll have to write 992. Okay? All right, so that's the result that we get. Okay, you could also calculate these individually. X equals 1, x equals 2, x equals 3, x equals 4. That will also give you the same result. Okay, all right. Now, this person, Wei, whatever, is a member of the same soccer club. He is also practicing scoring goals. The probability that he will score a goal on any attempt is 0.6, independently of all other attempts. He's going to keep making attempts. He's going to keep making attempts until he scores 3 goals. Find the probability that he scores his 3rd goal on his 7th attempt. Yes, Sufyan, you can write probabilities in fractions. That's acceptable. Yes. Okay. Now, find the probability that he scores his 3rd goal on his 7th attempt. Now, what kind of distribution is this? This is not geometric. This is not standard binomial as well. It's kind of a mixture of both of them. Now, let's try to understand this. His 3rd goal has to come on his 7th attempt. Okay? His 3rd goal has to come on his 7th attempt. Now, let's think about this. You got 1st, 2nd, 3rd, 4th, 5th, 6th, 7th. You got 7th attempts. You want a goal on the 7th attempt. This has to be a goal. But this has to be the 3rd goal. Okay? That means you need to have 2 goals before this already. Out of these 6, you need 2 goals. Now, they could come in any order. You could have this and this. You could have this and this. You could have maybe this and this. There are many different possibilities. Okay? But this has to be the 3rd goal. In these first 6 attempts, you need 2 goals. Okay? So what we can do is we can find the probability of scoring 2 goals in the first 6 attempts. Okay? In the first 6 attempts, find the probability of scoring 2 goals. So the first 6 attempts can be modeled as a binomial distribution. For the first 6 attempts, we could say it's a binomial. With n equal to 6, we know the probability of success, that is 0.6. Probability of failure, that is 0.4. Find the probability of getting 2 successes in the first 6. What do you get from that? 6c2 into 0.6 raised to power 2 into 0.4 raised to power 4. What do you get from this? What do you get from this? Anyone? .1382. So this is not your final result. So you need more accuracy. Do not round off yet. Use as many significant figures as you want. More than 3, minimum 4. Ideally, just use the exact value from your calculator. So 0.13824. Now, this is the probability of getting 2 successes amongst the first 6 attempts. And then after this, you want the 7th attempt to be successful as well. So what's the required probability then? You've got 2 successes in the first 6 already. You would say 0.13824 multiplied by 0.6 for a success in the 7th attempt as well. And that will give you the final result. You can see what this is. 0.6 into 0.13824, that is 0.082944. So that's 0.0829. That's the probability that you get. So what you're doing is you're breaking your problem down into 2 parts. You're saying, okay, the 7th attempt has to be the 3rd goal. That means you should already have had 2 goals before that. This is the probability of having 2 goals in the first 6 attempts. And then this is the probability of the 7th attempt being a goal. And that gives you this probability. Make sense? 62 is basically for deciding where exactly these 2 goals are going to come in the first 6, right? That's what 62 is for. That's how the binomial formula is basically derived. This tells you which 2 places are we going to have those 2 successes, okay? So we are saying, let's break it down into 2 parts. This is just giving us the probability of scoring 2 goals in the first 6. Now, at this point, we have already scored 2 goals in the first 6. And then the 3rd goal comes on the 7th attempt. What's the probability of scoring on the 7th attempt? The probability of scoring a goal in the 7th attempt is also 0.6. So we multiply this by 0.6. That's the probability of scoring on the 7th attempt. Wherever they are. 80% of the residents of 𝗪𝗏𝗃, I'm sorry, I don't know where that is, are in favor of a leisure center being built in the town. So 80% of the residents of this region are in favor of a leisure center. 20 residents from this region are chosen at random and asked in turn whether they are in favor of the leisure center. Find the probability that more than 17 of these residents are in favor of the leisure center. Now, how do we think about this? आपको question statement से पता चल रहा है, देखें वो क्या पूछ रहा है. Probability of having more than 17 residents who are in favor of the leisure center. Now, it's that statement that basically hints towards number of successes of something, right? Number of successes की बात हो रही है कि 17 से ज़्यादा जो है वो लोग favor में हो leisure center के. तो success को अगर हम ऐसे define कर दें, being in favor of the leisure center. If we define this as success, think about it. Can we categorize this or can we formulate this as a binomial distribution? Binomial की क्या condition होती है? We need a total number given. कितनी कोई चीज repeat होनी चाहिए. So we are choosing residents. We are choosing 20 residents in total. So क्या मतलब हुआ? N की value यहाँ पे क्या है? N की value है 20. So we have the total number defined here जो repeat हो रहा है. अच्छा. उसके बाद क्या होता है? You need to have 2 possible outcomes. अब अगर हम possible outcomes को इस तरह से कर लें कि एक, in fact यहाँ पे हैं ही 2 outcomes. एक कुछ लोग favor में है, कुछ लोग favor में नहीं है. There are 2 possible outcomes. The success हम क्या कह रहे हैं? Those who are in favor of the leisure center. Failure would be those who are not in favor of the leisure center. So we have two possible outcomes. One is success, the other is failure. The probability of success here is 0.8. You can see that 80% are in favor, so that's 0.8. Probability of failure is 1 minus that, which is 0.2. और ये probabilities change नहीं हो रही हैं, assuming that it's a large city, wherever this region is. 80% अगर आपके पास let's say 1 million भी लोग हैं यहाँ पे, तो एक आप निकाल भी लेंगे, उसमें से एक आपने पहले सेलेक्ट कर लिया, बाकी की प्रोबेबिलिटी कोई खास चेंज नहीं होगी, राइट? कोई नेग्लिजिबल डिस्टेंस है, सो यू कैन अज्यूम दैट द प्रोबेबिलिटीज रिमेन कांस्टेंट. जब पास बड़ा डेटा होता है उसमें आप अज्यूम कर सकते हो कि एक निकालने से भी आपका जो आपकी प्रोबेबिलिटी है वो चेंज नहीं हो रही एज सच. ठीक है, तो आप क्या कहेंगे? n is 20, probabilities remain constant. You have two outcomes, success and failure. आपको क्या करना है? Probability of having more than 17 successes. तो अगर आप एक वेरिएबल डिफाइन कर दें x, which represents the number of successes, you want more than 17 successes. That's what you're looking for. अब more than 17 successes का क्या मतलब है? Out of 20, you could either have 18 successes or 19 successes, or you could have 20 successes. These are the possible outcomes that you have. Now, what's the binomial formula? The binomial formula looks like this. It's given in the formula sheet as well, although it's in a slightly different form. NCR into P raised to power R into Q raised to power N minus R. That's how the binomial formula looks like. All you have to do is input values in that. N is 20, so that's 20 CR. R यहाँ पे 18 है first value के अंदर, so 20C 18 into P, which is 0.8 into 0.8 raised to power 18 into 0.2 raised to power 2. That's the first probability that we have. Now, similarly, input values in the rest of them, plus 20C19 into 0.8 into 0.8 raised to power 19 into 0.2 raised to power 1 plus 20C20 into 0.8 raised to power 20 into 0.2 raised to power 0. Now you have to evaluate these numbers. It's recommended that you write down these terms individually. Okay, उससे फायदा ये होगा कि अगर आपका आंसर for some reason एंड पे गलत भी आ जाता है, आपको ज्यादा पार्शियल मार्क्स मिल जाएंगे अगर आपने स्टेप्स शो किए होंगे. अच्छा, तो 20C18, अच्छा इसके अलावा ना आपको कैलकुलेटर में डालते हुए ब्रैकेट्स यूज करने पड़ेंगे, अदरवाइज आपका एरर आ जाएगा कैलकुलेटर पे. 20C18 into 0.8 raised to power 18 into 0.2 raised to power 2. ये आप देख लें फर्स्ट वैल्यू 0.13691. Then you have 20C19, इसको 19 कर दें यहाँ पे, 0.8 raised to power 19 and 0.2 raised to power 1. उसी को एडिट कर लें जो आपने पहले इनपुट किया है, and this is going to give you 0.057646. You have 20C20, essentially just 0.8 raised to power 20 रह जाएगा वो. That's 0.011529, which is 53. इन सबको ऐड कर लें, देखें आपके पास क्या आता है. This should give you 0.206, and that's the probability that we were looking for here. Okay, I hope that makes sense. This is what we had to do here. ये आपने ये सारे कैलकुलेट कर लिया, ये probability कैलकुलेट कर ली, greater than 18 वाले सारे केसेस ऐड कर लिए. ठीक है, let's move on. So this was question number 3, part A. Let's have a look at the second part now. It says find the probability that the fifth person asked is the first person who is not in favor of the leisure center. Okay, now notice the language used here. Probability that the fifth person is the first person. Does that remind you of something? बाइनोमियल में तो हमारा होता है कि नंबर ऑफ सक्सेसेस कितनी है. यहाँ पे फर्स्ट सक्सेस की बात हो रही है. फर्स्ट सक्सेस कहाँ पे होती है? ज्योमेट्रिक डिस्ट्रीब्यूशन में. सो ऊपर वाला जो था, दिस वाज बाइनोमियल डिस्ट्रीब्यूशन, Now this is a geometric distribution because you're looking for the probability of having this first success in a particular outcome. इसमें total number आपको पता होना जरूरी नहीं होता, लेकिन यहाँ पे success देखें कैसे defined है. आपने क्या find करना है? Not in favor of the leisure center. इसमें this is how success is defined. Okay, a person not being in favor of the leisure center, that is success. So that means in this case, the probability of success would be 0.2 because इसने कहा था 80% are in favor. Not in favor कितने होंगे? 20%. So probability for that is 0.2 here, and probability of failure is 0.8. And what we're looking for is the probability of having the first success on the fifth outcome. The first जो है वो favor में हो, second favor में हो, third favor में हो, fourth favor में हो, और फिर fifth जो है favor में ना हो. आप इसको logically वैसे भी कर सकते हैं कि 0.8 जो है वो 4 times आना चाहिए पहले, और फिर एक दफा 0.2 आना चाहिए. You can do it like this. That's one possibility. आप geometric distribution वाला formula लगा लें. उसके लिए क्या करना होगा आपको? Probability of x equals 5 ये figure out करनी है, और आप इसमें x का represent कर रहा होता है number of trials needed until first success. इसका formula हमारे पास होता है q raised to power r minus 1 times p. Let's just input value 0.8 raised to power 5 minus 1, that's just 4, into p with a 0.2. So essentially it's the same thing जो हम पहले logically कर रहे थे, and that should give you the result. Yeah, देख लें क्या आता है. 0.8 raised to power 4 into 0.2, that is giving me 0.0819. Okay, that's what we get in the second part. Let's have a look at the third part. And the third part, it says, find the probability that the 7th person asked is the second person who is not in favor of the leisure center. Okay. Again, we are talking about not being in favor of the leisure center. इसकी probability कितनी है? ये तो 0.2 ही है, not being in favor of the leisure center. लेकिन उसने कहा 7th person is the second person. Now think about it. सबसे पहले तो ये binomial या geometric हो सकता है. It's actually none of them, because geometric में हम सोच रहे होते हैं first success. यहाँ पे first success की बात नहीं हो रही, second success की बात हो रही है. Binomial में हम देख रहे होते हैं number of successes. यहाँ पे number of successes की बात भी नहीं हो रही, यहाँ पे second success की बात हो रही है. It's none of them. Or in a way you could also think it's a combination of both, because आप ये कह रहे हो कि 7th जो है, this should be a success, and we are defining success like this, of course. 0.2 हम success कह रहे हैं, probability not being in favor. Some 7 जो है वो success है, लेकिन उससे पहले वाले जो 6 हैं हमारे पास, first, second, third, fourth, fifth, and sixth. इन 6 में से सिर्फ एक सक्सेस होनी चाहिए. Out of these first 6, you could have only one success. अब वो एक सक्सेस कहाँ पर आ रही है? आप इतने पार्ट को एज अ बाइनोमियल फॉर्मुलेट कर सकते हो कि अच्छा इन 6 में से what's the probability of having one success, right? You could think of it like this. In 6 में से one success आने की क्या probability है? And you could write it like this: 6c1 into 0.2. In fact, यहाँ तो success यहाँ 0.2 raised to power 1 into 0.8 raised to power 5. That's one way of thinking about this. ये आपको इस part की probability दे देगा, multiplied by the probability of having a success on the 7th outcome as well. That would be 0.2. That's one possibility. कि आप पहले 6 को binomial में formulate कर लें और फिर उस तरह से कर लें. If that confuses you, you can think about the cases you can have. एक case for instance ये हो सकता है, first success आ जाए, बाकी जो है successes ना, और फिर second success 7th में आ जाए. That's one possibility, right? This is one possible case. इसकी probability कैसे आएगी आपके पास? First success, that gives you 0.2, and then you have 5 failures, that's 0.8. raised to power 5, and then you have one more success at the end, that's 0.2. Essentially ये क्या हो गया, 2 successes हैं तो उसके लिए आपके पास आ गया 0.2 का square, और फिर 5 failures हैं उसके लिए आ गया 0.8 raised to power 5. But do we have any other possibilities? देखें second success आपकी 7th case में आनी चाहिए, तो second तो यहाँ पर आ गई, and you can have one success before that, तो एक और possible case आपका ये हो सकता है, right? इसकी भी कितनी आपकी probability बनेगी, इसमें 2 successes आ रही हैं 0.2 raised to power 2 और 5 ही failures आ रहे हैं 0.8 raised to power 5, इसकी भी वही probability आ रही होगी आपके पास. अब इस तरह के कितने cases बनेंगे आपके पास? You can have the third case, the fourth case. Third में एक में आपके पास यहाँ पे आ जाएगा, फिर इधर आ जाएगा, फिर इधर आ जाएगा, फिर इधर आ जाएगा. तो टोटल कितने केसेस बन गए आपके पास? टोटल इस तरह के आपके पास 6 केसेस बनेंगे. So all you have to do is, ये जो एक probability आपके पास आ रही है 0.2 raised to power 2 into 0.8 raised to power 5, इसको आपने 6 times add करना है, because there are 6 possible cases like that, right? ये 6 cases बन रहे हैं आपके पास इस तरह के, ठीक है? तो आपने 6 times add करना है. That's the same thing as saying कि आप उसको बस 6 से multiply कर दो, and that will give you the required result. Okay? या अब देख लें क्या आता है. 0.2 raised to power 2 into 0.8 raised to power 5 into 6, and that gives me 0.0786. That is the probability that we were looking for in this case. Let's look at the next one. So let me see what other questions they've asked about in this paper. Okay, question number 5 is this. Let's try this. It says in a certain region, the probability that any given day in October is wet is 0.16. So probability of any particular day being wet is 0.16 independently of other days. Find the probability that in a 10-day period in October, fewer than 3 days will be wet. Okay. Find the probability that in a 10-day period in October, fewer than 3 days will be wet. Now, what kind of distribution is this? This is 0.16 probability of a day being wet. They're talking about a 10-day period. That's a fixed n. You want fewer than 3 days to be wet. That means fewer than 3 successes. If we call a day being wet a success, right? You would say a given day in October being wet, we call this a success. What's the probability of success? It's 0.16. Probability of failure, 1 minus this, that's 0.84. N is 6, N is 10. That's a binomial distribution because we are looking for the number of successes. We want the number of successes to be less than 3. Fewer than 3 means less than 3. So what are we looking for? Probability of X being less than 3. That's what we want to find out. Now in binomial, we don't have a direct formula for any inequalities, right? We have to find the probability for each one of these cases separately. X equals 0, X equals 1, and X equals 2, and then add them up together. Remember, in binomial, we also have to consider X equals 0. In geometric, we don't consider X equals 0. We only consider X equals 1 onward, because in binomial, we can have 0 successes as well, right? It's possible that you have no successes. That's a possibility, okay? Now you just apply a formula for this. What's the formula for binomial distribution? That's X equals R, probability of that is NCR, P raised to power R, 2 raised to power N minus R. Just apply that on each of them individually. You get 10C0 into P, which is 0.16, raised to power 0 into 0.84 raised to power 10 minus 0, which is 10, plus 10C1 into 0.16 raised to power 1 into 0.84 raised to power 9, plus 10C2 into 0.16 squared into 0.84 raised to power 8. Evaluate this, and that will give you this probability. It's better to evaluate all of these terms separately. That saves you from careless errors. But you can do it all together as well, as long as you are sure about your calculation. What do we get from this? Anyone can do this? 0.794. Okay, so the result that we get from this is 0.794. That's the probability. Now it says find the probability that the first wet day in October is 8th October. Now, what's that? First success. What does that remind you of? Probability of getting your first success on a particular outcome, on a particular attempt, that is geometric distribution. Probability of getting your first success on a particular outcome, right? So again, the probability of success is the same as before, because again, we're calling a day being wet as success. So first success, that's what we're looking for. Probability that the first success comes on 8th of October. That means it comes on the 8th day of October. This is what we're looking for. What's the formula for geometric distribution? Probability of x equals r. That's 2 raised to the power r minus 1 times p. This is input values there. Q is 0.84 raised to the power 8 minus 1. That's 7 into p. That's 0.16. And that gives you the answer. You can see what that turns out to be. 0.84 raised to the power 7 into 0.16. That's 0.0472. Okay, so you need to remember what you are looking for in binomial. In binomial, you're looking for the probability of having a certain number of successes. In geometric, you're looking for the probability of the first success coming on a particular attempt. Okay, so note the difference between the two probabilities that you're looking for. In one case, you're looking for number of successes. In the other case, you're looking for the probability of getting your first success in a particular attempt. Let's look at the next one. It says for 4 randomly chosen years, find the probability that in exactly one of these years, the first wet day in October is 8th October. Okay, now understand the statement well. For 4 randomly chosen years, we're choosing 4 years. Out of those 4 years, we need to find the probability that in exactly one of them, the first wet day in October is 8th October. Now, what's the probability of the first wet day in October being 8th October? We find that above. That's 0.0472. In this case, if we call this a success, first day in October being wet is 8th October. What's the probability of that? If we call this a success, we say probability of that is 0.0472. Okay, so in this case, we say this is how we are defining success. We are choosing 4 years. N is 4. Out of those 4 years, what's the probability that exactly you get exactly one success? There's exactly 1 year out of those 4 years where the first wet day in October is 8th October. So what's the probability that you have exactly one success out of 4? Probability of success is 0.0472. What's the probability of failure? You do 1 minus this. That's doing 0.9528. Okay, that's the probability of failure. We want the probability of having exactly one success. What kind of distribution is that? That's binomial distribution. We're talking about number of successes, getting exactly one success. NCR, P raised to the power R, Q raised to the power N minus R, that will be 4C1 into 0.0472 raised to the power 1 into 0.9528 raised to the power 4 minus 1, which is 3, and that should give you the result. Let's see what that turns out to be. What do you get from this? 4 into 0.0472 into That's 0.1633, right? So you can say to 3 significant figures, that's 0.163. That's the result that we get from this. Let's look at the next one. Now it says in a certain country, the probability of more than 10 centimeters of rain on any particular day is 0.18, independently of the weather on any other day. That means for every single day, the probability of it raining more than 10 centimeters is the same, and that is 0.18. ठीक है, हर दिन ये आपकी probability है of raining more than 10 centimeters. We have to find the probability that in any randomly chosen 7-day period, so you're talking about 7 days, more than 2 days have more than 10 centimeters of rain. So सबसे पहले हमें देखना है what kind of distribution is this? Probability देखें constant रह रही है. Probability is constant 0.18, that is not changing. So it could be either binomial or geometric. Binomial में क्या होता है, हम number of successes की बात कर रहे होते हैं. Geometric में क्या होता है, we are looking for the number of trials until the first success. यहाँ पे first success की बात तो नहीं हो रही, यहाँ पे हम देख रहे हैं number of successes. And how are we defining success? More than 10 centimeters of rain. That's our criteria for success. So success की probability क्या होगी? Success की probability क्या है? वो यहाँ पे उसने बताई हुई है, that is 0.18. We just write that 0.18. That's the probability of success. ठीक है? So this is binomial. We figured that out. Number of successes की बात हो रही थी, हम यहाँ पे side पर लिख लेते हैं, just so that we remember. This is binomial. Probability of success is 0.18. What about n? Number of times it's being repeated, the trial. It's a 7-day period. N की value यहाँ पे 7 है. These are the two parameters. Now, what are we looking for? Probability that we have more than 2 successes. More than 2 successes. क्या मतलब? Probability of x being greater than 2. ये figure out करना है. ठीक है? Now greater than 2 could be 3, 4, 5, 6, 7. या 5 probabilities calculate कर सकते हैं if you want, or you can do it the other way around. You can say this is the same thing as saying 1 minus probability of x less than or equal to 2. क्योंकि वहां पे आपको कम calculation करनी पड़ेगी. You can say 1 minus probability of x equals 0, minus probability of x equals 1, minus probability of x equals 2. 0, 1, 2 वाले cases 1 में से minus कर दें, and you'll get your result. Now, what's the formula that you've got for binomial distribution? You can write that down on the side. The formula sheet में दिया होता है. Probability of x equals r, that's NCR into p raised to power r into q raised to power n minus r. Formula sheet में थोड़ा सा different formula दिया होगा, उसने बस इस तरह लिखा होगा NR, NCR notation और ये notation. There's just different ways of writing combination. और फिर उसने लिखा होगा q की जगह पे उसने लिखा होता है 1 minus p raised to power r. That's the same thing. एक ही बात है. You have to use that formula in each of these cases. क्या करें आप? Formula के अंदर values input कर दें. You've got 1 minus probability of x equals 0. That's going to be NCR. N की value क्या है? 7. R की जगह पे यहाँ पे क्या आ रहा है? 0. 7C0 into p raised to power r. P is 0.18 whole raised to power 0 into q. Q यहाँ पे evaluate कर लेते हैं. 1 minus this, that's going to be 0.82. 0.82 raised to power 7 minus 0, it's going to be 7. Okay, minus 7C1 into 0.18 raised to power 1 into 0.82 raised to power 6. Remember, इन दोनों का sum हमेशा 7 आना चाहिए. ये भी 7 आना चाहिए, ये भी 7 आना चाहिए. जो भी आप calculation कर रहे हो, powers का sum यहाँ पे 7 होगा, because that's the total number n. Subtract from that 7C2 into 0.18 raised to power 2 into 0.82 raised to power 5, and that's going to give you the result. ठीक है? अब इस तरह लिख के हम क्या करेंगे? एक स्टेप और शो करेंगे जिसमें ये इंडिविजुअल नंबर्स लिखेंगे. ठीक है? इसके बाद सीधा आंसर नहीं लिखना, इसको इंडिविजुअली इवैल्यूएट कर लें. उसका फायदा ये होएगा, in case you get something wrong in the final answer, you will lose only 1 mark. अगर आप सीधा आंसर लिख दोगे और वो गलत हो गया, तो you could end up losing more than 1 mark sometimes as well. अच्छा, let's write that down now. ये हम यहाँ पे लिख लेते हैं. 1 minus 7C0 into 0.82 raised to power 7. That gives me 0.24929। एक्यूरेसी ज्यादा रखनी है ताकि फाइनल आंसर एक्यूरेट आए। 7C1 into 0.18 into 0.82 raised to the power 6, and that gives me 0.38305, and subtract from that 7C2 into 0.8 raised to the power 2 into 0.18 raised to the power 2 into 0.82 raised to the power 5, and that gives me 0.25225. Evaluate this now, you get your result 1 minus 0.24929 minus 0.38305 minus 0.25225, and that gives me 0.1154, which when we round it off, it becomes 0.115. You can leave it like this, and that's also going to be fine. आप ज़्यादा accurate कर सकते हो, and that's going to be okay. All right, so that's the result. Let's move on. Now it says for 3 randomly chosen 7-day periods, find the probability that exactly 2 of these periods have at least 1 day with more than 10 centimeters of rain. Now that statement sounds a bit confusing. Let's read that again. So take a few seconds and try to read that. For 3 randomly chosen 7-day periods. So now we've got 3 7-day periods. So basically 3 weeks आपने choose किए. उसमें से we have to find the probability that exactly 2 of these weeks have at least 1 day with more than 10 centimeters of rain. So this is basically a binomial inside a binomial. एक binomial के अंदर एक दूसरा binomial है. Okay? Now what's the outer binomial? एक binomial हमारा weeks की बात कर रहा है. Number of weeks कितने हैं? So we've got the outer binomial, यहाँ पे left पे लिखा होगा. इसमें क्या है? n is 3. n की वैल्यू 3 है और इसमें हमने क्या करना है? Probability find करनी है that exactly 2 of these periods have at least 1 day. So आपने 3 में से 2 की probability निकालनी है. लेकिन मसला क्या है? इसमें probability of success हमें नहीं पता. Probability of success इसके अंदर क्या होगी? We don't know. Success कैसे define किया उसने? Success इसने define की है at least 1 day with more than 10 centimeters of rain. So basically एक वीक के अंदर आपके पास एटलीस्ट 1 डे ऐसा हो जिसमें आपकी 10 सेंटीमीटर से ज्यादा रेनफॉल हुई है. वो आपका दूसरा बाइनोमियल है जो बेसिकली वो पहले हम ऊपर देख रहे थे, वो वाला बाइनोमियल. उसके अंदर n की वैल्यू क्या थी? n was 7 एंड प्रोबेबिलिटी ऑफ सक्सेस देयर. वहां पे सक्सेस क्या किस तरह डिफाइन हुई थी? वहां पे सक्सेस वाज डिफाइंड as more than 10 centimeters of rain. So basically एक हमारे पास वो अंदर वो ओरिजिनल बाइनोमियल है, उसमें 0.18 इसकी प्रोबेबिलिटी ऑफ सक्सेस थी and 0.82 was the probability of failure. उसमें हमें सबसे पहले फाइंड करना है what's the probability of having at least one success. At least one success. ये कैसे कैलकुलेट करेंगे? Probability of x greater than or equal to 1. At least 1 का क्या मतलब होता है? Greater than or equal to 1. Okay. Now greater than equal to 1 में क्या क्या आ जाएगा? 1 से लेकर 7 तक सारी possibilities. तो वो काफी ज्यादा मुश्किल ज्यादा लंबी कैलकुलेशन हो जाएगी. हम क्या करेंगे? इसको कर देंगे 1 minus probability of x equals 0. x equals 0 वाला केस रह गया सर, बस 1 में से माइनस कर दें and we'll get to result. Let's see what we get from this. 1 minus n is 7, 7c0 into 0.18 raised to power 0. ये सब कुछ तो 1 हो जाएगा. We are left with 0.82 raised to power 7. We have done this calculation above there. 7c0 वाला केस क्या था? It was coming out to be 0.24929. ये आप देख लें आपके पास क्या आता है? 1 minus 0.24929. This is giving me 0.75071. This is the probability of having at least 1 day with more than 10 centimeters of rain. ये आपने वो probability निकाली. ठीक है. अब ये जो है ये आपकी इस बाइनोमियल की प्रोबेबिलिटी ऑफ सक्सेस है. ये नंबर हम क्या करेंगे? ये जाके यहाँ पे लिख देंगे. दिस इज गोइंग टू बी 0.75071. अब ये आपका आउटर बाइनोमियल है जिसमें वीक्स की बात हो रही है, 7 डे पीरियड्स की बात हो रही है. इसमें 3 पीरियड्स हैं this is the probability of success. अगर ये probability of success है, probability of failure भी हम वहाँ पे लिख सकते हैं. What is that going to be? 1 minus this, which turns out to be 0.24929. That's the probability of failure. अब क्या करेंगे, इस पे binomial लगा देंगे. यहाँ पे आप weeks की बात कर रहे हो, तो यहाँ पे इस binomial में क्या calculate करना है? Out of 3 weeks, we want the probability that we get exactly 2 successes. Exactly 2 successes. Probability of x equals to आपने यहाँ पे find करना है. यहाँ पे remember x different चीज represent कर रहा है. यहाँ पे x number of weeks की बात कर रहा है. इस वाले के अंदर x क्या बात कर रहा था? Number of days की. So these are 2 different x's. ये आप calculate कर लें. n की value यहाँ पे 3 है into 3c2 into probability of success raised to power 2, 3.75071 raised to power 2 into 0.24929 raised to power 1. We evaluate this, and this is going to give us our result, 3 into 0.75071 plus square into 0.24929. And I'm getting 0.4215, or in fact 42147. If I round it off to 3 significant figures, which is not necessary again, if you want, you can do that. You get 0.421. Agar aap round off kare bhi, it's better to write the more exact number first, और उसके बाद आप राउंड ऑफ करके लिख दें. तो उसका फायदा ये होगा, अगर आपसे गलती भी हो जाए कोई राउंड ऑफ करते हुए, तो वो एग्जामिनर अक्सर क्या करता है, आपका ये वाला आंसर मार्क करके आपको फिर भी मार्क्स दे देता है. Okay. All right. So that's your final result here. This was binomial inside a binomial. This is the more complicated type of question that you can get in binomial. This is what you were supposed to do here.